Welcome back to part 2 of our module number 2. Okay, so it is strain. So we have here problem number 1. According to your module, the steel propeller shaft ABCD carries an actual loads shown in the figure. So you have here 2,000 pounds at point A, you have 6,000 pounds at point C, and you have 4,000 pounds at point D. Okay, determine the change in the length of the shaft caused by these loads. Use E as 29 times 10 raised to 6 psi. So we can solve for the force on A, force on C, and force on D by using the equilibrium equation. But like what we have discussed on our first meeting, we can solve it with the help of the axial diagram. Okay, so with the help of axial diagram, it would be much easier. So the force on A is tension, okay, because it is pointing away from our cross-sectional area. Therefore, it is positive. Okay, so that is positive 2,000. So that is 2,000. So along the line of action from point A to point C, there is no change or addition in loading. So that's why it is only going to be a straight line. Okay, so up to point C. Now, as the 6,000 pounds is opposite the direction of the 2,000 pounds. Therefore, the 6,000 pounds is compression. So 2,000 minus 6,000, that would be negative 4,000. So that is negative 4,000 pounds. And there is no additional or change in loading from point C to point D. So this will be a straight line. Then the load at point D, which is 4,000, is the same as the direction as the 2,000 pounds, which is in tension. Therefore, 4,000 would also be in tension. So it will go back to 0. So the start is 0 and the ending point is 0. So from our diagram, the force from A to B is 2,000 pounds. The force from B to C is also 2,000 pounds. And both are in tension. Okay, so that's positive. But the force from C to D, so PC to D, is equivalent to negative 4,000 pound, or it is equivalent to 4,000 pound, but it is in compression. Okay, so to get the total deformation from this propeller, we are just going to simply get the summation. So the deformation is simply the summation of all of these, the summation of all of the deformation on these three segments. So A to B, B to C, C to D. So that would be the summation of forces PL over AA. Okay. So this is equivalent to 1 over E. We factor out E because we have the same E for all of the material, which is 29 times 10 raised to 6. Okay. So this is times of AB plus PL over A of segment BC plus PL over A of segment CD, or material CD. So substituting the value, we have 1 over E. What is E? E is equivalent to 29 times 10 raised to 6. Okay. So pagkasyahin natin sa screen, times 6 is times what is P of segment AB? So that is 2,000 pounds. Okay, so 2,000 pounds times the length of 5 feet. Okay, so we convert the feet into inch because we are dealing with PSI, pound. So this is equivalent to pound per square inch. Okay, so the length is 5 feet times, you have 1 foot is equivalent to 12 inches. Okay, so divided by the area. What is the area? You have pi over 4 times the diameter of 0.5 squared. So this is for segment AB, plus for segment BC we have, again, P is 2,000 times, we have the length of 4 times 1 foot is equivalent to 12 inches divided by the diameter of pi over 4, or the cross-sectional rather, pi over 4 times 0.75 quantity squared. This is for segment BC, plus for segment CD we have P of negative 4,000. So instead of positive, we change this to negative. Okay, so it is negative. So 4,000 times the length of 4 feet times 4 feet times, you have 1 foot is 12 inches divided by the cross-sectional area of pi over 4 times 0.75 quantity squared. So quantity. So we have here, we have 1 over 29 times 10 raised to 6 times 2,000 times 5 times 12 divided by pi over 4 times 0.5 squared plus 2,000 times 4 times 12 divided by the cross-sectional area or minus rather, minus 4,000 times 4 times 12 divided by the cross-sectional area of the fourth segment and that is equivalent to 0.01358 inches. Okay, so this is the deformation, or what we call the elongation of our propeller. Okay, so this is the elongation of the material. Next, we have number 2. Okay, so from your module, we have here the cross-section of a 10 long meter flat steel bar. Okay, the flat steel bar AB. So you have here A and you have here B. AB has a constant thickness of 20 mm. So if we are viewing it on this way, so the thickness here is 20 mm of that steel bar. But its width varies as shown. So from 40 mm, nag-vary siya hanggang 120 mm yung kanya width. calculate the elongation of the bar due to a 100 kilonewton axial load. So, hihilain siya on this two side, on both sides. So, we are to determine the elongation on this on this material using the modulus of elasticity as 200 gigapascal. Okay, so since our cross-sectional area is changing, we are now going to use the equation. Deformation is equivalent to the integral of P dx with over E times area from 0 to L. So we're going to use this equation. Now, we have P. Our P is 100 kilonewton. Next, our E is 200 gigapascal. Now, the problem is the area. Take note that the area that we're considering is at any point on this cross section. Okay? So, hahanapin natin or we need to derive our equation for the area. So, solving for the area, the area at point A, is 20 times the thickness of 20 mm. So that would be 40 mm times 20 mm, and that is equivalent to 800. So that is 800 mm squared. Now we have the area at B. So the area at B is equivalent to, we have here the width of 120 mm times the thickness of 20 mm. So that would be 2,400. So in between A and B, take note that the relation of the cross-sectional area is a linear function. So therefore, to get that equation, A is equivalent to, since we're going to have our reference with respect to point A, we have A plus, we have the area at B minus the area at A times at any point along this 10 meter material divided by the total length. Okay, so substituting the value, we will be having 800 plus, we have the area of 2,400 minus 800 times x, because x is at any point along this 10 meter distance, divided by the total length of 10 meter. Okay, so simplifying, we have 800 plus 1,600 divided by 10 times x. So this is equivalent to 800 plus 160x. But take note, this equation is in mm squared. So we need to convert it to make it consistent with the units. Okay, so we need to multiply it by, for every 1,000 mm, we have 1 meter. And quantity squared, mm squared will simply cancel out. So this is 800 plus 160x times 10 raised to negative 6. So we already have our value for, or equation for A. We can now proceed with our integration. So what is our P? P is equivalent to 100 times 10 raised to 3, and that is in newtons. You have dx divided by E. So you have 200 times 10 raised to 9. That is in newton per mm. Newton per meter. But if you want it to have it in millimeters, then or to eradicate rather 10 raised to 9, just simply have it at Newton per mm. Okay, squared times, what is our A? We have 800 plus 160x times 10 raised to negative 6. Okay, so this is also in meter squared, so that is meter squared. So meter squared and meter squared will simply cancel out. Okay, so 10 times 100 times 10 raised to 3, it will simply cancel out. May matitirang 6, 10 raised to 6. 10 raised to 6, then we have here 10 raised to negative 6. It will also simply cancel out. So we have 100 divided by 200, we have 0.5 times the integral of dx over 800 plus 160x. Okay, then we input it in our calculator. So yeah, we have here 0.5 times the integral from 0 to 10. From 0 to 10. Okay, so times the integral of dx over 800 plus 160 of x from 0 to 10. So on my case, as long as it is already it is already manageable by the calculator to be calculated, then there's no need to simplify. It is to save time because we're already done with your integral calculus. What's important is you know, and you will be deriving at the same answer as mine. So we have 3.433 times 10 raised to negative 3, and that is in meters. And this is equivalent to 3.433 mm. So this is our elongation or the deformation for this material.